Our lesson today about solving quadratic equation in one variable. As we studied in graphically, there are many methods to solve the quadratic equation. First, we will remember how to solve quadratic equation algebraically. The general form of quadratic equation is ax power 2 plus bx plus c equals 0. A is the coefficient of x power 2, b is the coefficient of x, and c is the determinant. What we mean by the determinant means the term without any x. We take the general formula for solving quadratic equation x equals negative b plus or minus square root b power 2 minus 4ac over 2a. This is the general formula for solving any quadratic equation. For example, solve the quadratic equation x power 2 minus 5x plus 6 equals 0. Who can say a equals 1 and b and c? Excellent. As we said before, a is the coefficient of x power 2. So a will equal 1 and b coefficient of x. So b equal negative 6. C is the greater. So b equals 6. Then we will substitute in the general formula for a by 1, b negative 5, c by 6. After that, we can calculate by using calculator or by our mind. So we will get x equals 2 and 3. So the solution set for this quadratic equation is 2 and 3. Another example. Find the solution set of each of the following equations in R. A x power 2 minus 1 equals 0. B x power 2 plus 3x equals 0. In the first one, who can say what is the value of A and B and C? A equals 1, B equals 0, very good. Why? Because there is B is a coefficient of x and there is no x. So B equals 0 and C, which is the preterm, is negative 1. Then we will substitute in the general formula. So x will equal negative 1 plus or minus root negative 1 power 2 minus 4 times 1 times negative 1 over 2 times 1. Then we will calculate the value of x. We will get that x equals 1 and negative 1. So the solution set for the quadratic equation in A is 1 and negative 1. E. Who can determine the value of A, B, and C? First, A equals, while B and C, A equals 1, B equals 3, C equals B. B Be careful about determining the values of A and B and C. Then we will substitute. So we'll get -3 plus minus square root 3 power 2 minus 4 times 1 times 0 over 2 is 1. X will equal 0 and -3. We put the value of x in at x and put it as a solution. Now, it's the turn to solve. How to solve quadratic equation graphically. We also studied this solution in self-grade. We will make a quick revision about it. In each of the following graphs, the quadratic function is the one, and we want to find the solution set of the equation. In the first one, A, the curve is in blue. The curve is in blue. The curve is in blue. Intersect the x-axis at the point -2. So the solution set for the first graph is -2. In the second, the curve never intersects the x-axis. The curve is above x-axis. So the solution set in B will be far. Why? Because in the graphical solution, the value of x is the point of intersection between the graph and x-axis, and there is no intersection point. In the third one, the curve intersects x-axis at -2 and 1. Now we will draw the curve itself. Draw the graphical representation of the function f of x equals x power 2 minus 4x plus 3. In the interval, -1 and 1. And from the following, find the solution set for the equation x power 2 minus 4x plus 3 equals 3. We will open our calculator and select the move button. You will find so it's 7 is called table. We will choose table. The function will arrive on x3 x of x equal. Then you will write x power 2 minus 4x plus 2. Then press equal. The word start will appear. Start means the start of the interval, which is -1. You will write -1 and equal. The word end will appear. End means the end of the interval, which is 5. So you will press 5 and press equal. There is a word set and the value is 1. We will change this value. This table will appear in the calculator. When x equals 5, y equals 8. When x equals 4, y 3, 3 and 0, 2 and -1, 1 and 0, 0 and 3, -1 and 8. We will do it again. we will find that the curve intersect the x-axis at 1 and 4. At 1 and 8 and 4. So, the solution. Now, with another example, solve the equation x power 2 plus x minus 6 equals 0 graphically. Then check your answer. Taking x belongs to interval negative 4 and 3. We will establish the table by using calculator. We press mode, then 7, and write the function x power 2 plus x minus 6. Then press equal. Will give you start, which is the start of the interval. You will write negative 4. Then end, the end of interval, which is 3. Then we will press equal, give the step, and it is always P1. Then press equal. The following table will appear. You will write it. Then you will graph the curve for the quadratic function. The curve intersects the x-axis at negative 3 and 2. So the solution set for this equation will be negative 3 and 2. Now, another example. The curve is already drawn. We want only to find the solution set. In A, what is the solution set? Excellent. Since the curve intersects the x-axis at negative 3 and 2, so the solution set will be negative 3 and 2. P, what is the solution set? Very good. Negative 3 and 0. C, the solution set is, good job, 1 and 5. Now we will start the first lesson in secondary 1, which is an introduction in complex numbers. We will discuss the example solving the quadratic equation x power 2 plus 1 equals 0. As we learned before, A is equal to 1, B coefficient of x, there is no x, so P will be 0, C, the free term is positive 1. By using general formula, x equals negative 0 plus and minus root 0 power 2 minus 4 times 1 over 2 times 1. So x will be positive negative root negative 4 over 2. Till step 3, we say that the solution set is 5. Now, we will learn how to find the square root for the negative numbers. We will put root negative 1 equals I. Then x will equal root negative 1 times root 4 over 2 times 1. Root negative 1, which is I, and root 4 is 2, so x will be positive and negative 2i over 2. We will simplify, so x will be positive and negative I, where I is the square root for negative 1. I is a complex number, not a real number. In step 3, we will solve the equation in the real numbers. So the solution set is 5. Now, in complex numbers, the solution set will be positive and negative I. What is imaginary numbers? Imaginary numbers is defined as the number whose square is negative 1 and is denoted by I. as we said, I is the root for negative 1. I equals root negative 1. I power 2 equals root negative 1 power 2, which is negative 1. I power 3 equals I times I power 2. So I power 2 negative 1 times I. So I power 3 will equal negative I. Also, I power 4 will be I power 2 times I power 2. So it is equal negative 1 times negative 1, which equals 1. We must know that I power 2 negative 1, I power 3 equals negative I power 4 equals 1. I power any multiple of 4, I power 4n equals 1. But what about I power 4n plus 1? We said that I power 4n equals 1, so the remainder in the power will be 1. I power 1, which equals I. We will practice more about the powers of I. In the next example, simplify. The first one, I power 12. Excellent. 12 is a multiple of 4. So I power 12 will equal 1. I power 12 will divide 12 to I power 4 all power 3. I power 4 1. 1 power 3 equals 1. Number 2, I power 100. 100 is a multiple of 4. So I power 100 will equal 1. I power 41. Who can say? 41 is a multiple of 4? No. Which number is near to 41 and multiple of 4? Excellent. 40. So it will equal I power 40 times I power 1. I power 40 is 1 times I. So I power 41 equals I. What about I power negative 3? It isn't a multiple of 4, but I can solve it by multiplying 1 times I power negative 3. And I equals, 1 equals I power 4. I power 4 times I power negative 3. We will add the powers. 4 plus negative 3 will be 1. So it is equal I power 1. So I power negative 3 equals I. Next one, I power 28. 28 directly is a multiple of 4. So I power 21, power 28 will be equal 1. I power 18. Is 18 a multiple of 4? Of course not. Which number is a multiple of 4 and near to 18? Very good, 16. So it will be I power 16 times I power 2. I power 16, it's a multiple of 4, so it will be 1. I power 2, as we learned it before, is negative 1. 1 times negative 1 will be equal to negative 1. The next one, I power 4n plus 3. 4n is a multiple of 4, so I power 4n is 1. The remainder will be I power 3. And as we learned it, I power 3 is negative I. So the answer will be negative I power negative 19. Again, we will consider I power negative 19 equals 1 times I power negative 19. We will substitute for 1 by I power 20. 20 is a multiple of 4, so I power 20 is 1. 20 plus negative 19 is 1. So it will be I power 1. Another example about different powers for I. Find in the simplest form I power 24, I power 37. It's similar to the previous example, and we will let it for you as an exercise and we will discuss discuss the answers in the next session. Now we will know the definition of the complex number. A complex number is a number which can be written in the form a plus bi, where a and b are real numbers. The complex number is divided to a real part, which is a, and imaginary part, which is imaginary part p, which is related to I. For example, solve the quadratic equation 2x power 2 minus 1 equals negative 9. It's so easy. We will make negative 1 in the other side will be positive 1. 2x power 2 equals negative 8. We will divide by 2. X power 2 will equal negative 4. By taking the square root, we will put positive and the negative root negative 4. Root and under the root negative, so it will give us I. And the root of 4 is 2. So x will be 2 positive and the negative 2i. 2 is called the imaginary part. Now what about real part? There is no real part. Here is it's a 0. So the solution set will be positive and the negative 2i. Now we will learn more about complex numbers. Equality of two complex numbers. Two complex numbers are equal if and only if the two real parts are equal and the two imaginary parts are equal also. So if a plus bi equals c plus di, the real part here is a and here is c, so a equals c. Imaginary part P will equal imaginary part B, and vice versa. Example, find the values of x and y which satisfy the equation where x and r and y are real numbers and I power 2 equals negative 1. We will make equality about real parts. So 2x minus y will equal 5, and x minus 2y, which is imaginary part, will equal 1. We will solve these two equations with each other. How? By multiplying a second by negative 2 and add 1 and 2. We will get 3y equals 3, then y equal 1. By substitution for y equal 1, we will get x equal 3. Or we can use the calculator to simplify the solution. When we solve two equations in two unknowns, we will press mod 5, 1, then press 2, negative 1, 5, and 1, negative 2, 1. Then equal, we will get the values for x and y. Now we will take another exercise about equality of two complex numbers. Find the values of x and y which satisfy the two equations. And I left it as an exercise, and we will discuss the answer in the next session. Now we will learn how to add and multiply and subtract and make the four operations on complex numbers. The example, find in the simplest form the result of each A, B, C, D. In the first, we will add the two complex numbers. How I can add these two complex numbers? I can add these two complex numbers by adding real part to real part and imaginary part to imaginary part. So 7 plus 2 and negative 4 plus 1, which gives us 9 minus 3i. In the second, we want to multiply. How to multiply two brackets? I'll multiply 2 by 3, 2 by negative 4i, 3i by 3, 3i by negative 4i. First, 2 by 3 equals 3, equals 6, sorry. 2 times negative 4 equals negative 8, and don't forget I. 3i times 3 equals negative I. 3i times negative 4i, negative 12i power 2. Like any, the product of two brackets. Then I'll use the probabilities for I. Here, the 6 is a real part, so it remains as it is. Negative 8i plus 9i gives us 1i. I power 2 equals negative 1. 12 times negative 1 will be negative 12. 6 minus 12 will be negative 6 plus I. So I make a product of two complex numbers. C, 2 plus I power 2. Like any bracket power 2, when we make an expansion for a bracket power 2, first power 2, 2 power 2, first times second times 2, second power 2. 2 power 2 equals 4. 2 times 2 times I gives us 4i. I power 2, which is negative 1. We have two real parts, 4 and negative 1. 4 plus negative 1 equals 3, and 4i will remain as it is. Number D seems to be different. In D, he gives us 5 plus 2i power 100. And it is so difficult to multiply the bracket by itself 100 times. What I can do? I will simplify. How I can make simplification? I will make 100 2 power 50. Because when there is a power raised to another power, we multiply 2 powers. 1 minus I power 2, the first power 2. First times second times 2, the second power 2. And don't forget power 50. Then 1 power 2 gives 1. 2 times 1 times negative I gives negative 2i. I power 2 equals negative 1. The 1 plus negative 1 will give 0. So it will be negative 2i power 50. I will distribute the power. So it gives us 2 power 50 and I power 50. What about negative sign? In second period and first period also, we learned that if the number is negative and the power is even, the result will be positive. So the negative sign neglected. I power 50. 50 isn't a multiple of 4. What is the nearest multiple of 4 to 50? 48. Excellent. So it will be I power 2. I power 2 equals negative 1. Negative 1 times 2 power 50 will give us negative 2 power 50. Here is another example. Try to solve is the difference between two complex numbers, multiplying two complex numbers in B and C. And I will let them for you as an exercise, and we will discuss the answers in the next session. Now we will learn more about complex numbers. The conjugate numbers. The conjugate numbers, if I have a complex number a plus bi, its conjugate will be A minus PI. So the two conjugate numbers, A plus PI and A minus PI. I change the sign of the imaginary part. For example, 4 minus 3i, its conjugate is 4 plus 3i. What about the sum of two conjugate numbers? If I make summation for a number and its conjugate, the imaginary part will be deleted because negative 3i plus 3i will give 0, and the real part will be multiplied by 4. So the answer will be 8. So the sum of two conjugate numbers will give us a real number, which is twice the real part. What about the product of two conjugate numbers? I will multiply 4 minus 3i by 4 plus 3i. In the product of two conjugate numbers, the answer will be the square of the real part plus the square of imaginary part. Here, the real part is 4, so the answer will be 4 power 2 plus the imaginary part is 3 plus 3 power 2. 4 power 2 equals 16 plus 3 power 2 equals 9. The answer will be 25, and also it is a real number. So we get this conclusion: the result of sum and the product of two conjugate numbers is a real number. Now we will use the conjugate numbers. What is the benefit of learning conjugate numbers? Or it is useless? It's very important, and we will know that in this example. Find the values of x and y which satisfy the equation. Here, it is an equality between two complex numbers. And as we said before, the real part will equal a real part and the imaginary part will equal imaginary part. But the real part in the left side isn't clear. So I must simplify the left side. How I can simplify it? First, I will make a multiplication for two numbers, and they are two conjugate numbers. So it will be the square of the real part plus the square of the imaginary part. It will give us 5 over 3 plus 4i. How I can make the denominator disappear? By timing with its conjugate in the numerator and denominator. It will give us 5 times 3 minus 4i over 25 equals x plus iy. So the real part, which is x, will equal 3 over 5, and the imaginary part, which is y, will equal negative 4 over. Here is another example about using the conjugate number. Try to solve. Find in the simplest form the value of each of the following. And all of them has denominator. How I can remove the denominator? By timing by its conjugate. And I let it as an exercise for you, and the answers will be discussed in the next session.